Is SD-WAN just a VPN over the internet? Is it a replacement for MPLS? Is it a routing protocol? Or is it something more than that? In the previous video, we looked at why SD-WAN exists. We saw that the WAN problem changed because applications moved to the cloud, branches gained multiple transport options, and organizations needed more centralized control, better application experience, and more flexible security. In this video, we'll define SD-WAN more clearly. We'll look at what SD-WAN is, what it is not, and why it is better understood as a modern WAN architecture. Let's start with the name. SD-WAN stands for Software-Defined Wide Area Network. The WAN, or Wide Area Network, is the part of the network that connects locations together. For example, it connects branch offices, headquarters, data centers, remote sites, cloud environments, and sometimes users. The software-defined part means that the behavior of the WAN is controlled more centrally, using software-based management, policies, and automation. This does not mean that there is no hardware. There are still routers, circuits, interfaces, tunnels, routing protocols, firewalls, and real packets moving across real networks. But SD-WAN changes the way those components are controlled and used. So here's a simple definition. SD-WAN is a WAN architecture that uses centralized management, secure overlays, multiple transports, and policy-based control to connect sites and applications more intelligently. That definition is important because it keeps us away from some common misunderstandings. SD-WAN is not just one protocol, it's not one box, it's not just a VPN, it's not simply internet instead of MPLS, and it's not magic. SD-WAN is an architecture. It's a way of designing, operating, securing, and controlling the WAN. Now, one of the most important ideas in SD-WAN is the difference between the underlay and the overlay. Now, we will be devoting a whole video to this topic, but at this point, what I can say is that the underlay is the real transport network. This could be MPLS, broadband internet, fiber internet, LTE, 5G, or another type of WAN connectivity. The underlay provides the actual packet transport and forwarding. The overlay is the logical SD-WAN fabric built on top of those transports. The overlay usually uses secure tunnels between SD-WAN edge devices. These tunnels allow different sites to communicate across different transport networks as part of one single WAN fabric. So SD-WAN does not replace the underlay, it actually uses the underlay. Now, another important part of what makes SD-WAN SD-WAN is that it separates different functions of the network into planes. We have the management plane, which is used for configuration, monitoring, visibility, templates, and operational control. This is part of SD-WAN's centralized management capabilities. The management plane provides administrators with a central management system that is used to configure, monitor, and operate the WAN more consistently. Then we have the control plane, which is used to distribute routing, policy, and fabric information generated by the management plane. Finally, we have the data plane, which is where user traffic is actually transmitted and forwarded. So the management plane controls the fabric, the control plane distributes intelligence, and the data plane forwards the traffic. Additional features that define SD-WAN include things like policy-based control, application-aware routing, security, and segmentation. Now, because we've already talked about policies, securities, and application-aware routing in a previous video, I'd like to focus more on the segmentation here as a feature that sets SD-WAN apart and defines it. Now, segmentation is something we apply as part of network design. We typically group network devices into specific subnets, VLANs, and layer 2 domains based on their functionality. We may have servers in one segment, printers in another segment, and actual user end devices in still another segment. But SD-WAN takes this one step further. In SD-WAN, segmentation means that different types of traffic can be kept logically separate across the WAN. For example, corporate users, guest users, voice traffic, IoT device traffic, and sensitive business systems may all need different treatment. In traditional networking, we may use VRFs, VLANs, ACLs, and firewall rules to create this separation. But in SD-WAN, segmentation can be extended across the WAN fabric itself, so that different logical networks can share the same physical transport while still remaining separate. Now, I know these concepts can be difficult to fully grasp at first, especially if you have not worked with SD-WAN before. It often takes some time to understand not only what SD-WAN is, but also what it changes in the way WANs are designed, managed, and operated. And even if you've worked with SD-WAN, you may have learned it in a fragmented way. One feature here, one vendor term there, one configuration task at a time, and so on. So you may have used parts of the technology without having a clear overall picture of how everything fits together. Hopefully, this video has helped to clarify the big picture, to remove some common misconceptions, and to fill in any gaps you may have had about what SD-WAN actually is. So these are the characteristics of SD-WAN. So what is SD-WAN? SD-WAN is a modern WAN architecture. It's not a product, it's not a VPN, it's not a transport technology. It uses secure overlays over one or more underlay transports. It separates functionalities into planes of operation, and it segments traffic across the WAN fabric. It also allows system-wide policies, application-aware routing, and security policies across the whole WAN. So SD-WAN should be understood as an architecture for building and controlling the modern WAN. In the next video, we will look at one of the most important concepts in SD-WAN, the difference between the underlay and the overlay. Once you understand the underlay and overlay, many SD-WAN concepts become much easier to understand. Subscribe to the Telecom Tech channel and enable notifications so you can follow the complete series and be informed of every new video. I'm Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. I hope this has been helpful for you, and I'd like to thank you for watching.